Alright guys, I thought I would do an Algebra 1 cumulative first week's test review here. We're going to run through just what we ran through in class, only at a relatively fast pace because this is going to be a video, so you can stop and go back, watch things again. There are 10 concepts that we're going to cover for this unit, and we will start with concept 1. So we'll just take our first example, x, or rather 2x equals 4. Solve for x. Okay, so in order to solve for x, I divide both sides by 2, and these cancel out on the left, the 2's cancel out, and I have x equals 4 over 2. Now, 4 over 2 can be reduced. So now you must reduce. Okay? And we can reduce 4 over 2 to 2, because 4 divided by 2 equals 2. X equals 2. Right, now imagine a situation where it was reversed. Let's try 4x equals 2. Solve for x. Okay, in this case, we're going to divide both sides by 4, and we have x equals 2/4 or 2 over 4. Now, can I reduce this? Yes. So now, reduce the fraction. We can divide both the top and the bottom by 2, and so 2 divided by 2 is 1, and 4 divided by 2 is 2. So we have x equals 1/2, or 1 over 2. And that's our solution for this type of problem. Now, we can complicate this problem a little bit. Again, we're going to be solving for x, but we're going to introduce a couple of more complications. So now imagine you're given this. 2/3 x plus 7 equals 7x. And I say solve for x. Okay, so in this case, I will start by getting my terms together, combining like terms, and I want the x on the left and the other terms on the right. Remember, 2/3 x and 7x are like terms. So if I want to gather those like terms, I will subtract 7x from both sides. And on the right side, 7 minus 7 is 0, x minus x is 0, so 7x minus 7x minus 7x is 0. This cancels out on top. And now I have 2/3 x minus 7x plus 7. I cannot just combine these terms because they do not have a common denominator. 2/3 x and 7 do not share a common denominator. See, the denominator up here is 3. The denominator for the negative 7 is 1. So what I really need to write if I rewrite this equation is 2/3 x minus 7x plus 7 equals 0. Okay, so let's continue to move variables and numbers around. Let's try to get all the x's by themselves. Remember, I want to solve for x. So first, let me get rid of this 7 on the left. So I subtract 7 from both sides. This goes to 0, and this is negative 7 now. Okay, so rewrite my equation. 2/3 x minus 7x equals negative 7. So we're getting close. Now we have to deal with this denominator situation. I need 7 in terms of 3. When I mean 7 in terms of 3, I mean I need to write down a number that equals 7, where the denominator is 3. So the way you do this is if you want the denominator to be 3, here's how you do it. So let's rewrite part of this, 2/3 x minus, okay, and now I'm going to do this computation here. I'm going to multiply 7x by 3 over 3. Okay, and you have to remember that 7 really means 7 over 1. So I have 3/3 times 7 over 1. And it's okay to do this because 3 over 3 is just 1. 3 divided by 3 is 1. So 3/3 times 7 over 1, x. Okay? Equals -7. So let's do that multiplication. 3 times 7 is 21. So I now have 21/3. So let's rewrite 2/3 x minus 21 over 3 x equals -7. Now I can actually continue to subtract here because I have now a common denominator for the coefficient associated with the variable x. These numbers are the coefficients, 2/3 and -21/3. So what is 2 minus 21? It's -19. So I have this, minus 19 or -19/3 x equals -7. Okay? So I still want to get x by itself. In order to get x by itself, I have to divide out this fraction, -19/3. We can't do it the normal way. So what we do is we multiply by the reciprocal. Okay, multiply by the reciprocal. What does that mean? Well, this is -19/3. What is the reciprocal of that? Is just -3/19. So I'm really multiplying out the left side, and I have to do the same thing on the right, -3/19. Well, what is that? What is -3 times -19? Well, we can do that little side over here. 19 times 3, that's 7, 2, so 57. Negative times a negative is a positive. And then on the bottom, I have to multiply 19 times 3. Okay, well that's also 57. Okay, so I end up with 57 over 57x on the left, and this goes to 1. 57 divided by 57. So you see how they cancel out. If you wanted to do it a different way that's easier, you don't have to do all the multiplication. You can just notice that 3's cancel and the 19's cancel. So everything cancels out, leaving just x by itself. Equals -7 over 1 times -3 over 19. So what we end up with is x equals, what is -7 times -3? Well, that's a negative times a negative is a positive, and 3 times 7 is 21. So I end up with 21 over 19. So that's your answer. This cannot be reduced because 19 is a prime number. So we just leave it like that. Your answer choices on the test will be fractions like this. Now there is a way to kind of work your way through the problem that might be a little bit easier for you if you don't want to do all of that complicated math. And let me show how that's done on the calculator. What you do on the calculator is go to Math, hit the Math key, and go down to, for you it's B, Solver. Okay, so open up the solver app, and then you see E1. We'll just put in your original equation, which was 2/3 x plus 7 equals 7x. So you're just going to put this into the calculator. So the way we do that is we're going to type it in just as it appears. If you don't know how to find the equal sign, you hit second math. Second math brings up this table here, and you can choose to add an equal sign if you want. Another way you could do this is by putting the left side of the equation in E1 and the right side of the equation in E2. It really doesn't matter. And then you go down and, whoops, I hit the wrong button. That is not the button I wanted to hit. Let me go back to where I was. Apologies. Okay, so now I think it's going to make me put in both. So I'm going to put in the left side of the equation on E1 and then the right side of the equation on E2. It's making me put it in to get that OK symbol to come up. So then I hit OK and clear out whatever's in there for x, put a 0, and then hit alpha solve, okay, which is alpha and then the enter key. And it says that x equals 1.1052, all that. So you just make a note, x equals 1.105263. So that's what we're looking for in our answer key, 1.105263. So let's go back down to the way we solved it algebraically. This would be an answer choice, 21/19. So the way we do this is get out of that solver function and put in 21/19 over 19 and divide it out. Now look, 1.0526, compare that to what you found using solver. They're the same. So that's how you know that it's correct. So the key here is in your answer choices, make sure you divide out your fractions if you're given fractions to find the decimal, if and only if you're using the solver method. Ideally, you would solve it algebraically, but if you get stuck, use solver and do it where you back plug the answers. It's just a test-taking strategy. Okay. Now we're on to some easier material. We're going to solve functions. F of x equals 2x plus 6. So I want to solve for f of 3. What is f of 3? Well, f of 3, the way you do it is you put equals, and then wherever you see an x, you just plug in a 3. So 2, and then replace the x with a 3 plus 6. And then you just kind of multiply it out. So this equals 2 times 3 is 6. So you have 6 plus 6, and that equals 12. So f of 3 equals 12. How about f of 0? F of 0 equals 2 times 0 plus 6. So f of 0 just equals 2 times 0 is 0. F of 0 just equals 6. And then f of 1, 2 times 1 plus 6. Okay, 2 times 1 is 2, plus 6 is 8. So f of 1 is 8. That's how you solve these functions. Okay, I want to make sure that you can identify the slope and y-intercept when you're given an equation in slope-intercept form, which is y equals mx plus b. Remember, m is the slope and b is the y-intercept. So if I give you y equals 3/7 x plus 49, and I ask you, what is the slope and what is the y-intercept? M, or slope, equals 3/7. Okay, and B, or y-int, equals 49, positive 49. What if I had said y equals 2x minus 2? All right, well, in this case, m equals 2, and b, or the y-intercept, equals negative 2. Okay, you have to carry the sign. Pay attention to that sign that's in front of your y-intercept. All right, so that is identifying the slope and y-intercept. Now we're going to do a stat, edit, stat, calc, linreg, ax plus b problem. Well, what does this problem mean? Well, when you're given coordinates, let's say you're given coordinates 1, 2, and 7, 8. Those are your coordinates that you're given. And I want you to find me an equation for a linear equation in the form y equals mx plus b, which is the slope-intercept form. So how do you do this on the calculator? Well, let's get our calculator back out. Okay, clear out what's in there. And you hit, let me get everything in view here. Okay, we're going to hit stat, edit, and if there's anything in there, clear those lists. Don't delete the lists, clear the lists. And for L1, we're going to put our x values. This is x1, this is x2, y1, y2. We're going to put our x and y values. So for L1, we put the x values. That's 1 and 7. And for the y values, we're going to put 2 and 8. Now, we hit stat again, go over to calc, and go down to linreg ax plus b, enter, 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 calculate. And what it tells you is a is 1 and b is 1. Okay, so it says a equals 1, b equals 1. The one thing we need to remember is that a in this calculator is m, the slope, okay, and b is still the y-intercept. So if I asked you to give me an equation in mx plus b, or slope-intercept form, using these coordinates, you would use stat, edit, stat, calc, linreg, and you would come up with y equals, and then the slope is a here, so you'd put in 1x, but you don't have to write the 1. We'll write it for now. 1x, and then plus, and then b would be 1. 1x plus 1. Well, we don't have to write that 1 in front of the x, so we just write y equals x plus 1. So that's your mx plus b form of the line using these coordinates. So that's the stat, edit, stat, calc, linreg computation. All right, moving right along. Constant rate of change, or CROC. In this case, you're given an x and y table, right? Imagine you're given this table, and here's 2, 4, 6, 12, 12, 24, and 14, 28. How do I know what the constant rate of change is? Well, you can just observe that 4 divided by 2 is 2, 12 divided by 6 is 2, 24 divided by 12 is 2, and 28 divided by 14 is 2. So the constant rate of change is 2. So here the CROC equals 2. Okay? So that's constant rate of change. Next up, function. Is it a function? All right, so we're going to find out whether things are functions. Let's look here at a graph. Real quick graph. And I have this graph here. Now this is y and this is x. Is this a function? No, because it fails the vertical line test. It fails it right here and everywhere else. So no, not a function. How about if I have x here and y here in a table? I'm given a table of values, and I've got 0, 1, 2, 2, 9, and 0, 0, 0, 1, 1. Is it a function? No, because there's a repetition of the two values. So no, that's not a function. How about a map? Here's a map. X here, Y here, and here I've got 1, 2, 3, 4, 5, 6, 7, 8. Now imagine that this is the map I draw. Is this a function? No, because this 1 has two y values associated with it. So in other words, the x value 1 is used twice. This is the same way as if you had seen 1 and then 1 in two rows of your table. So again, this is not a function. Now we'll talk about continuous and discrete. Remember, a continuous function kind of looks like this. That's a continuous function because it doesn't ever fail the vertical line test. Okay, but it's also a continuous function because there is no point where this is not defined. But let's look at a function that might not be continuous, and we'll see why it isn't continuous. And the name for a function that is not continuous is discrete. Remember, all tables and all maps are discrete functions. So here is my y and x. There's my origin point. And I'm just going to sketch in a quick graph here. This is going to be 4. Here down here will be -4. Here will be -3, and over here will be 7. Okay? Now I'm going to plot some points here. I'll plot right here a solid darkened in point, and then up here I'm going to plot in an open circle and connect these lines. Right, so my question is, what is the domain and the range? Oh, first of all, we should say this is, depending on the domain and the range, this is not a continuous function. Because if I were to continue drawing out, I would have this open circle here. Open circles are not good for continuous functions. So, but let's look at domain and range now. So my range values are the y values that this graph can take on, and the domain are the x values that this graph can take on. Okay, so what is the, let's start with domain. What is the domain of this function? Well, let's look at this value over here. The x associated with this value is -3. So this goes from -3, and then the highest x value associated with this function is 7. So we put 7 over here. Okay, remember with domain is going to be x. The only question is, what inequality symbols do I put in here? Well, for this one, because it's circled in, it's less than or equal to. -3 is less than or equal to x. Now over here, because it's an open value, I just put less than. So that's the domain. It's important to take note of these less than or equal to and less than symbols. Now how about the range? What is the range? Well, we know it's going to be in terms of y. The lowest value is -4, and the highest value is 4. So I put in here -4 and 4. Again, looking at this lowest value, it's colored in, so we put less than or equal to. -4 is less than or equal to y, but on the upper value, it's an open circle, so it's just less than. So there's your domain and range for this graph. And remember, just as a side note, if you have a graph where the values or the graph itself is a line like this, so once you establish that it's a function, which it is, the domain and range are -infinity, less than or equal to x, less than or equal to +infinity for domain, and for range it's -infinity, less than or equal to y, less than or equal to +infinity. Okay, that's for this one. So that's domain and range. All right, and now we're going to work on this word problem. So this is the one that was confusing to some people. A baker bakes 23 cakes during his first hour at work. He bakes 54 cakes in his second hour at work, and 72 cakes in his third hour at work. Okay, so there's your setup. A baker bakes 23 cakes during his first hour at work. I wrote his twice. All right. He bakes 54 cakes in his second hour at work and 72 cakes in his third hour at work. So the question is the baker's output of cakes a function of his time spent baking the cakes? Now, most people's gut reaction to this is to say that it is a function, because it sounds like, yeah, the amount of cakes he makes is based on the amount of time he works. But let's find out if it's really a mathematical function. Okay, so first we need to identify what is our independent and dependent variables. So the x is the independent variable. Independent. And y is the dependent variable. So what depends on what? Does cake depend on time, or does time depend on cake? Dependent. Okay? Well, according to the logic of this proposal here, this scenario, the independent variable is time. That's what they're proposing. And the dependent variable is the output of cakes. So what we're being asked is, are cakes a function of time? Well, let's find out. So let me make a table here. X and Y. This is time, and this is cakes. So what were my cakes in the first hour? 23. What were my cakes in the second hour? 54. What were my cakes in the third hour? 72. So how long did it take them to bake 23 cakes in the first hour? Well, it took them 1 hour. So 1 hour. How long did it take them to bake 54 cakes in the second hour? It took them 1 hour. And how long did it take them to bake 72 cakes in the third hour? Well, it took him 1 hour. See, it took him 1 hour to bake each of these amount of cakes. So it appears that we have a repetition of this number 1. Therefore, no, cakes are not a function of time. Why not? Because it took him the same amount of time to bake all these different amounts of cakes. So we have the x repeating. You could just say the independent variable is repeated. If I were to graph this, by the way, it would fail the vertical line test. So if I were to graph this, I would have 1 hour right there plotted, and then I would have all these values. I'd have 23, 54, and 72 would all be plotted in that 1 hour time slot. So I would create this vertical line here, and it would fail the vertical line test. It fails the vertical line test, so it can't be a function. Okay? Finally, we need to convert standard form to slope-intercept. Let me give you an example of what I'm trying to do. I want to go from ax plus by equals c. I want to go from there and convert to y equals mx plus b. That's what I want to do. And you say, well, how the heck do I do that? Well, let me show you. Let's do a real example. I'll take 7x plus 3y equals, 5. Okay, so again, minus 7x on both sides. And this goes to 0 here. And I have 3y equals minus 7x plus 5. Divide by 3 on both sides. And then y equals minus 7/3 x plus 5 over 3. Remember, I split this term up. So now I'm in y equals mx plus b form. M equals negative 7/3 and b equals positive 5 over 3. Okay? So that is the only thing that's not covered in this review is the inequalities calculations, which you have another video that covers. So graphing and solving linear inequalities is covered in that video that we did to review for the test. Other than that, we have covered everything that's going to be on the test tomorrow. So I hope this was helpful. Thank you.